Haha! Yesterday I left you with a cliffhanger. Today we are going to be doing more fraction comparing with benchmarks to compare two fractions on a number line. We're going to be doing some number bonds with it. Hopefully by the end you'll be able to fluently compare two fractions whether they are greater than or less than one whole. So let's get to it. The fractions that we're going to start with today, our first one is going to be 5/3. And our second one is going to be 9/5. Now, with these two fractions, what can we notice about them? Right away, hopefully you do too, I notice that this fraction right here is greater than 1 whole. That's good. However, I notice that this one is also greater than 1 whole. So the problem is, yesterday we dealt with a fraction that was greater than 1 whole and one that was less than 1 whole. So right off the bat, you were able to say, hey, using what I know about benchmarks, that benchmark being 1 whole, I can clearly see that this fraction is greater than this fraction. Well, today we're dealing with two fractions that are both greater than 1 whole. Dang. So using a number, whoops, whoa, you could have seen that. I dropped my pen all over the place. Using a number bond, we're going to do 5/3. We are going to do 9/5. Now, when we deal with number bonds, with fractions, we should be looking for our benchmark, and especially if the fraction is greater than 1 whole, our first number bond bubble should identify that it is 1 whole. So how many thirds make 1 whole? 3/3. We want to get to 5/3. How many thirds are left over? 2/3, because 3 plus 2 equals 5. So good, we got that first one done. Now we are going to go to this number bond. Our first bubble should represent a benchmark. So our benchmark in 9/5 would be 1 whole. 1 whole in fifths would be 5/5. And what's our leftover? 5 plus what equals 9? 4/5. 5/5 plus 4/5 equals 9/5. 5 plus 4 equals 9. Our denominator is 5. So go back over here. We have 1 whole, 3/3. We have 1 whole plus an additional 2/3. So our mixed number is 1 and 2/3. And here we have 1 whole plus an additional 4/5. So we look at our mixed numbers and we can see now that they both are over 1. And I notice another interesting thing, and that is that they are both 1 away from 1 whole. So 2 needs 1 more third to be 1 whole. And this 4/5 need 1 more fifth to be 1 whole. So that'll be interesting that I don't see an obvious out yet. So let's go to our number line. Since we know that our fractions are greater than 1, we should partition our number line from 0 to 1 to 2. And the first one I'm going to put on there is 5/3. 3 being my denominator, I need to partition this number line into thirds. There, 0 to 1, partitioned into thirds. The second whole, 1 to 2, partitioned into thirds. And why am I erasing? Because these should be as equal as I possibly can get them. I did fine. Not terrific, but fine, they're equal enough. Now I'm going to label out my fractions. I have 0/3. I have 1/3, 2/3, 3/3, and like we talked about in the last video, that it could go with improper fractions and go 4/3, 5/3, 6/3. However, this is another 1/3 to signify 1 and 1/3, and this is 2/3. This is another whole. All right, we need to mark down 1 and 2/3. So we need to go to our benchmark, 1, and an additional 1 2/3. So 1 and 2/3 is right there. Now this next part, 9/5. To make my partitioning easier, I want to get an even number on the bottom. Now we've talked about this a couple times. Why would I want to get the even number on the bottom? It is because an even number, a factor of any even number anywhere ever, always has to have a factor of 2. 2 times something always equals an even number. Problem is here, 5, I could just wildly guess in my partitioning and have to erase a lot. However, what multiple of 5, the closest one, when you're skip counting by 5s, what is an even multiple of 5? 5, 10, whoa, 10. 10's an even number. 10. 5 times what equals 10? 5 times 2. 5 times 2, if I multiply the denominator by 2, I must multiply the numerator by 2. 9 times 2 is 18. Excellent. So now 9/5 is equivalent to 18/10. I'm going to partition my number line into tenths. Partition that into 2. And then I can go with 1, 2, 3, 4. Now I have fifths there. 1, 2, 3, 4. Fifths there, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This side I'm going to partition in half. What times 2 equals 10? That's 5, so I'm going to partition 1, 2, 3, 4, 5. Now right here I can see that my half must not be extremely equal because that looks a lot more equivalent than it should. But that's all right. 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What did I do wrong? Oh, I see it. Do you see my mistake? I partitioned this into 1, 2, 3, 4, 5, 6. That's why that didn't look right. Always be on the lookout for a mistake. Everybody makes them. Just a chance to learn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's way better. Okay. So now I'm going to label out my fractions. I have 0 tenths, 1 tenth. Go ahead and label out all your fractions. Hopefully you remembered that we're dealing with we're dealing with mixed numbers and not improper fractions. Hopefully you've picked up and gone with 1 tenth, 2 tenths, 3 tenths. All right. Hopefully you got your number line labeled into tenths. So again, right here, we have marked out, first, we marked out 5 thirds, or 1 and 2 thirds. Now we're after 9 fifths, which would be 18 of these tenths. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 1 whole. 11, 12, 13, 14, 15, 16, 17, 18. Right there. That is our 9 fifths, because 9 fifths is equivalent to 18 tenths. So we can see now that it was a close race, man. But 9 fifths is greater than 5 thirds. Now, when we talked about this right here, I made an observation and said that the numerator is just 1 away from the denominator. They're just 1 away from being 1 whole. So why is it that this was closer? Shouldn't they be equal? They're both 1 away from being 1 whole. Well, the issue lies in the denominator. The smaller the denominator, the larger the piece. The larger the denominator, the smaller the piece. So the smaller the denominator, the further away from 1 whole you are. The larger the denominator, the closer to 1 whole you are. So let's look at our number line right here. I'm going to see if I can get a nice highlighter color. Okay. If we look at 1 fifth, that would be right here to right here. That's a good sized distance. But looking at 1 third, that is quite a bit further away from 1 whole than 1 fifth is. So the size of the pieces, no matter if we had discussed that they are 1 away from being 1 whole, the size of the piece was what made all the difference. So in this lesson today, we took 2 fractions that we couldn't get right off the bat. We couldn't see that one was obviously greater, because we found that we made the observation using a benchmark that they were both greater than 1 whole. Then we made a number bond. Our first bond was find 1 whole, which was 3 thirds, and what was left over. We found out that 5 thirds as a mixed number is 1 and 2 thirds. Then we went to 9 fifths. We found what 1 whole would be, which would be 5 fifths. And what was left over was 4 fifths. We had 1 as a mixed number. We had 1 and 4 fifths. Then we looked at a number line. And thirds was pretty easy, because thirds follow along with benchmark fractions. fifths were a little bit different. I made the observation that if you had an even number, you could cut it in half and then partition the halves. So we found a fraction that was equivalent to 9/5 that had an even number denominator. We found the closest even number multiple of 5, which was 10. 5, 10. So we multiplied both the numerator and the denominator by 2. Found out that 18/10 was equivalent to 9/5. So we just partitioned our number line into tenths because it was easier. We counted out and found that 18/10 is right here, which is 9/5. Then we looked at our pieces, the size of the piece, to determine that thirds are larger pieces than fifths, so that would put them further away from 1/2. We came to the conclusion that 5/3, when compared to 9/5, 5/3 is less than 9/5. So these fractions that are greater than 1/2, they take a little bit more work.